Exercise 10.3 Vector Algebra. Question number 11. Show that vector A modulus times vector B plus vector B modulus times vector A is perpendicular to vector A modulus times vector B minus vector B modulus times vector A for any two non-zero vectors A and B. So let's write modulus A as A and modulus B as B. Then A times vector B plus B times vector A dot. Since they are perpendicular, the product must be 0. So A B vector minus B A vector. Now we do dot product. So this will become A square B square, and here it will become AB A dot B. Then these two will become AB B dot A. Then B square A square, because modulus A square or vector A whole square is A square, or vector A dot vector A will give A square, and A dot B equal to B dot A. So these two terms will cancel out, and this is A square B square, this is also B square A square, this will also cancel out. Hence we will get 0. So we can say that the two vectors are perpendicular. This one and this whole thing is perpendicular. Now question number 12. If A dot A equal to 0 and A dot B equal to 0, then what can be concluded about vector B? Here, if A dot A equal to 0, it means A square equal to 0. That gives modulus of vector A is 0. If A dot B equal to 0, it means either vector B equal to 0 or vector A is perpendicular to vector B. So here, since A is 0, so B may be any vector. In that case, product will be 0. So our answer will be that B may be any vector, because we are going to multiply with 0 to a vector. So result will be will be 0. Now let's go to question number 13. If vector A, vector B, and vector C are unit vectors, it means modulus A equal to modulus B equal to modulus C must be equal to 1, such that A plus B plus C equal to 0. So let's find out the dot product of A plus B plus C with itself. A plus B plus C. Now, A dot A will give A square, and we know that modulus A is equal to unity, so A square will also be unity. So it will become A square plus B square plus C square plus twice of A dot B plus twice of B dot C plus twice of C dot A. Now, here A square, B square, C square, all three are 1 because they are unit vectors. 1 plus 1 plus 1 plus 2 times. And we are given the product A plus B plus C equal to 0. So dot product will also give 0. So here we can write 0. So twice of A dot B vector plus B dot C vector plus C dot A vector must be 0. So this is 3. So we take this 3 to RHS, twice of A dot B plus B dot C plus C dot A equal to -3, or A dot B plus B dot C plus C dot A must be equal to -3 by 2, which are required answer. Now question number 14. If either vector A equal to 0 or vector B equal to 0, then A dot B equal to 0. Clearly, if A dot B equal to 0, it means either A equal to 0 or B equal to 0. Also, we know that if vector A is perpendicular to vector B, in that case also we get A dot B equal to 0. So that is why converse need not be true. So here it is not necessary that these two vectors are 0. If they are perpendicular to each other, still result will be 0. Let's consider one example. Suppose 2i minus 3j plus 5k, and b is another vector which is 4i plus 6j plus 2k. If we find dot product, so it will be 8 minus 18 plus 10, which will be 0. So a dot b equal to 0, it does not imply that vector a is 0 and vector b is 0. So let's go to question number 15. If the vertices ABC of a triangle are given, suppose we are given here, this is A, which is 1, 2, 3. This is B, which is minus 1, 0, 0. And this is C, which is 0, 1, 2. And we have to find out angle ABC. It means this angle is to be found. For this purpose, we have to find out the two vectors, this BA and BC. So we evaluate the two vectors BA and BC. So what will be BA? BA will be coordinates of A minus coordinate of B. So that will give, so it will be 2i plus 2j plus 3k. And BC means coordinate of C minus coordinate of B. So BC will be equal to I then plus j plus 2k. Now we find modulus BA, that will be equal to 2 square plus 2 square plus 3 square, root 17. Similarly, modulus BC will be equal to root of 1 plus 1 plus 4, root 6. Now we apply formula cos theta equal to, suppose this is, we write it vector A, this as vector B, then vector A dot vector B divided by modulus of vector A modulus of vector B. So we find the dot product of the two. So that will be 2 plus 2 plus 6. 2 plus 2 plus 6 divided by root 17 times root 6. That is 10 divided by root 102. So theta equal to cos inverse 10 upon root 102. Now let's go to question number 16. Show that the points are collinear. So here we find AB vector. AB vector will be difference of the coefficients. So 2 minus 1, that is I cap, plus 6 minus 2, 4 j cap, plus 3 minus 7, minus 4 k cap. And now we find modulus AB. So that will be a root of 1 plus 16 plus 16, that is root 33. Similarly, we find BC. BC equal to, first let's write the vectors. So this will be I cap, then 10 minus 6, that is 4 j cap, and then minus 1 minus 4 k cap. So here modulus BC, if we find, that will be equal to root of 1 plus 16 plus 16. So this will be root 33. Now we find AC. So let's write the vector first. vector AC will be equal to C minus A. So that will be 3I minus I, that is 2I, and then 10 minus 2, 8J, and then minus 1 plus, plus no, minus 8K. Here, if we directly compare it in terms of vectors, still it is true. Vector AB plus vector BC is equal to vector AC, because this sum of the two I will become 2I, 4J will become 8J, and 4K will become 8K. So still we can say they are collinear. Now, so that vectors this and this form the vertices of right angle triangle. So we are given three vectors, 2I minus j plus k. Suppose this is vertex A. Then B is 3I minus 4j minus 4k, and sorry, this is 2I minus j plus k, and this is, so B should be here. This is C, and let's write B here. B is I minus 3j minus 5k. We have to prove that these are the vertices of right angle triangle. So here we have two options. Either we find the dot product. If dot product of any two vectors will be 0, then we can say that they form the vertices of right angle triangle, or we can use Pythagoras theorem. So let's find out vector AB. So vector AB means difference in coefficient B minus A. So B minus A means I minus 2I. So that will give minus I, then minus 3J plus J plus 2. So it will be minus 2J, then minus 5K minus K. So minus 6K. Here we can find modulus AB. So that will be equal to root of 1 plus 4 plus 36. This is root 41. Similarly, we find BC. So difference in C, and this will give 2I, then minus 4J plus 3J, that is J, and then minus 4K plus, so this will be K. Now we find modulus BC. So that will be 4 plus 1 plus 1, that is root 6. And similarly, we find AC. So AC will be 3I minus, so AC 3I minus 2I, that is I, and then minus 4J plus J. So minus 3J and minus 4K, this is minus 5K. So if we find the modulus of this, so this will be equal to root of 1 plus 9 plus 25. This is 35. This is root 6, not 61. So this is 35 root. Clearly, BC modulus square plus AC modulus square is equal to AB modulus square, which is Pythagoras theorem, because BC square will become root. This will give 6 plus this will give 35, and this will give 41. So which is true. Hence, we can say that it forms the vertices of right angle triangle, and AB is hypotenuse. It means this angle C is 90 degree. Now let's see next question. If vector A is non-zero, vector of magnitude A, and lambda A non-zero scalar, then lambda A is unit vector if. So condition is lambda A modulus must be unity if it is unit vector, or we can say modulus lambda times modulus A must be equal to 1, and the modulus of vector A can be written as A. So modulus lambda times A equal to 1. or modulus lambda will be 1 upon A, or A equal to 1 upon modulus lambda, which is correct option. Thank you for watching.